course framework, we are going to determine the trigonometric function for any angle. We will follow these 3 steps, which are: first, identify the position of the angle, and then we will determine the reference angle, which is alpha, and the third one, we will calculate the value of the trigonometric function. Before we determine the trigonometric value for any given angle, we need to get to know reference angle. Reference angle is also known as basic angle. This is the characteristic of reference angle. First, it is denoted by alpha and is also located between the terminal side and the x-axis. We also know that alpha will always be an acute angle where alpha will never be greater than 90 degree or pi over 2 radian. Lastly, alpha is also always positive, which means we will never get a negative value for reference angle. How do we determine the value for the reference angle for any given theta? It will depend on the positioning of theta in our quadrant. Let's take a look when theta is in the first quadrant. Then our reference angle will also be the same value as theta. Alpha will be equal to theta. In the second quadrant, we will have the reference angle is equal to 180 degree minus theta because we will take the smaller part of the quadrant. In quadrant 3, when we have our theta in this quadrant, our alpha will be equal to theta minus 180 degree. As for in quadrant 4, our reference angle alpha will be equal to 360 degree minus theta. Now let's look at example 6. Determine the reference angle of the following. So we need to find alpha. For question A, we are given theta is equals to 46 degree. We know that 46 degree will be in the first quadrant. So we also know that in the first quadrant, alpha is always equal to theta. So alpha will be 46 degree. For the second question, we are given theta is equals to 340 degree. When we draw the diagram, we know that theta will be in the fourth quadrant. And to find alpha, the formula for the fourth quadrant is alpha is equal to 360 minus theta. So we get here 360 degree minus 340 degree. So the answer for alpha is 20. For question C, now we are given a different pattern because our theta is a negative angle where theta is equals to negative 135 degree. So take note that the angle will go in a clockwise direction. Now when we draw, we will get that theta will be in the third quadrant. However, take note, since the angle is a negative angle, the formula that we use for the third quadrant is almost like the formula for the second quadrant. Alpha will be equal to 180 degree minus theta. To get the value of theta, here our theta has a negative sign. That is to indicate that the position of the angle is going clockwise. So what we do is we just ignore the negative sign. We just take 180 degree minus 135 degrees. So we get our alpha is 45 degree. Same as the last example, we are given theta is equals to negative 235 degrees. So when we draw, we will get that our theta will be in the second quadrant. However, since theta is a negative angle, the formula for the second quadrant now will be the same as the formula for the third quadrant. So we have alpha is equal to theta minus 180 degree. Same as before, we just take the value, not the symbol for theta. So we just take 235 degree minus 180 degrees. So we get alpha is equal to 55 degree. So for the negative angle, we just ignore the negative sign when we are calculating the reference angle. Next, we are going to find the values of trigonometric functions by using reference angle. Given sine 120 degrees, how do we calculate this? By using the reference angle. First, we have to determine the location of theta. Theta is equal to 120 degree and will be in the second quadrant. We know that in the second quadrant, alpha will be 180 degree minus theta. So we will have alpha is equal to 60. And we also know that in the first and the second quadrant, sine theta will be positive. So we can just rewrite this. sine 120 degree is equal to sine alpha. So here we can just substitute, our alpha will be 60, so we are just rewriting this. Sine 120 degree is equal to sine 60 degree, and by using the special angle, we know that sine 60 degree will be 0.8660. As for the second example, we have tangent 225. First, again, we have to determine the position of 225 degree. It will be in the third quadrant. So in the third quadrant, our alpha will be theta minus 180 degrees. So we will have alpha is equal to 45 degree. And we also know that tangent theta will be positive in the first quadrant and also in the third quadrant. So we can just rewrite tangent 225 degree is equal to tangent alpha. Substituting alpha equals to 45, we will have tangent 45 is equal to 1. Now let's take a look at example C. We are given cos of negative 210 degrees. So first we need to determine the position for negative 210 degree. Since it is a negative angle, our angle theta will be in the second quadrant. And we know that in the second quadrant, to find the reference angle, we will use the formula alpha is equal to theta minus 180 degrees. And since our theta is a negative angle, we just take the value, not the sign. So 210 minus 180 degrees will give us alpha is equal to 30 degrees. And next, because we need to evaluate cos negative 210 degree, which is in the second quadrant, we know here cos will be negative because in the second quadrant only sine theta will be positive. So we can rewrite cos negative 210 degrees is equal to negative of cos alpha, where our alpha is 30 degree. So negative will just follow, and cos 30 degree will take the value 3 over 2 from the special angle. So for the last example, example D, we are given cos 315 degree. So again, we determine that 315 degree will be in the fourth quadrant, and our alpha will be obtained from the formula alpha is equal to 360 degree minus theta. So 360 degree minus 315 will give us alpha is equal to 45 degree. So again, here we need to evaluate cos 315 degree, which is in the fourth quadrant, and we know cos theta in the fourth quadrant will be positive. So we can just rewrite cos 315 degree will be equal to cos alpha, which is cos 45 degree. And by using the special angle, again, we can get cos 45 degree will be set 2 over 2.